In physics, we often need to work with multiple forces acting on an object. Force composition allows us to combine several forces into a single resultant force, while force resolution helps us break down a force into components. These techniques are essential for analyzing motion and equilibrium. The component method is the most systematic approach for force composition. First, we choose a coordinate system. Then, we resolve each force into x and y components using trigonometry. Next, we sum all x components and all y components separately. Finally, we calculate the magnitude and direction of the resultant force using the Pythagorean theorem and arctangent function. Force resolution is the opposite of composition. We break down a single force into components along chosen directions, typically x and y axes. The x component equals the force magnitude times cosine of the angle, while the y component equals the force magnitude times sine of the angle. This technique is essential for analyzing forces on inclined planes and an equilibrium problem. Let's apply force resolution to a practical example. A block on an inclined plane. The weight of the block acts vertically downward. We resolve this weight into two components, one parallel to the incline that causes the block to slide down, and one perpendicular to the incline that presses the block against the surface. The parallel component equals mg sine theta, while the perpendicular component equals mg cosine theta. Force composition and resolution have many practical applications in physics and engineering. They are essential for equilibrium analysis, where the sum of all forces equals zero. Engineers use these principles in structural design, analyzing forces in bridges and buildings. In summary, composition combines multiple forces into a single resultant, while resolution breaks a single force into components. Both techniques are fundamental tools for understanding and analyzing force systems in the physical world.